Friends, today we are starting the new chapter. This chapter is related to magnetic properties of atoms and molecules. You see how magnetism is produced. We will discuss about it, what is the origin of magnetism. Then we will also define magnetic field intensity. And finally, we will talk about the famous force which is known as Lorentz Force, and we shall also define the SI unit of magnetic field intensity Tesla. We will define 1 Tesla. So here you have to pay attention. So we will talk at first what is the cause of magnetism. Finally, we will talk. We will also talk about magnetic field intensity, and then we will finally talk about Lorentz force. We will also define the SI unit of magnetic field intensity, that is 1 Tesla. So now let us start. Whenever any charged particle is moving, immediately a magnetism is produced around it. This we will also prove it mathematically in the coming chapters. So what is magnetism? Now we have the basic idea. The moving charge are able to produce magnetism around its path. That is magnetism, and that is the source region, and hence therefore most of the atoms which are magnetic in nature, because the electrons are revolving around the nucleus of each atom, and it happens to produce magnetism around its path, and therefore the atoms are in general magnetic in nature. Now in some cases you see that the body is not showing magnetism. This is only because those individual magnets may not be arranged in one direction. They may be randomly arranged to cancel each other's effects. But in few of the cases you will also see, you happen to see that if the electrons are having opposite movement in opposite directions, and that cancels the effect of magnetism produced by each other, then in that case the atom is not magnetic at all. So those materials are also there. We shall be discussing such things in the coming chapters. So now we move to the next topic, magnetic field intensity. What is magnetic field intensity? We denote it by capital B. If you consider a unit north pole placed somewhere, then whatever force acting on this unit north pole due to the magnetic field present over there is known as magnetic field intensity, and it is denoted by B. So we can mathematically we can write magnetic field intensity B is equal to force per unit magnetic north pole, unit north pole. But one thing we have to remember, that in practice we don't have an isolated north pole. This is theoretically defined, that force per unit north pole is magnetic field intensity. The SI unit for magnetic field intensity is Tesla, and from this definition, if you write for force, you have the dimension, you have the unit Newton, and the pole strength is given by ampere meter. Now how it comes we shall be learning in the coming chapter, but for the time being I want to quote the formula which we are using here, is that magnetic dipole moment is equal to Ia. We shall be proving it in the coming chapter, and that is also equal to the pole strength multiplied by the length of the dipole. This definition is similar to the definition for electric dipole, in which in case of electric dipole we define magnetic or electric dipole moment P is equal to charge into length of the dipole. Here we are talking about magnetic dipole moment is equal to pole strength into length of the dipole. So from this, on equating magnetic dipole moment equal to Mn2L and is also equal to Ia. From that we have Mn is equal to Ia by 2L, and I is nothing but in ampere. A is cross sectional area, so it is in meter square, that divided by meter. So 1 meter in the numerator is cancelled by 1 meter in the denominator. So we are left with I. For I we have ampere, and for A by L we have meter. So that means pole strength, SI unit of pole strength is ampere meter, and therefore SI unit of Tesla is Newton, that is for force, and divided by ampere meter, that is for pole strength. And from this we have the dimension of magnetic field strength B is equal to dimension of Newton, that is force, MLT minus 2, and divided by dimension of ampere and meter. So that means ampere into L, A into L. So L in the numerator, L in the denominator, L in the numerator, L in the denominator, they cancel each other. So we are left with M, A to the power minus 1 and T to the power minus 2. This is the dimension of magnetic field intensity. Now we are going to talk about Lorentz force, and definition of 1 Tesla we shall be deriving it from this relation. What is Lorentz force? Whenever a charged body is moving in electric field, it experiences a force which is according to the definition of the electric field intensity. Electric field intensity is defined as force per unit charge. So total force on E charge will be E into E. E is the charge on the particle, and capital E is the electric field intensity at that point. So this is one part of the Lorentz force. Another part of the Lorentz force is E V cross B. This is called electric Lorentz force. This is called magnetic Lorentz force. Now E is the charge on the charged particle moving with velocity V in a magnetic field. B experiences a force equal to E into V cross B. So this from this magnet expression for magnetic force, Lorentz force, we have F is equal to EV cross B. So if we expand the cross product, we have magnetic force is equal to E into V magnitude, B magnitude sin theta, where theta is the angle between the velocity of the charged particle moving in magnetic field, and B is the magnetic field intensity existing. Therefore, you see, we can write B equal to magnetic Lorentz force divided by charge divided by velocity divided by sin theta. And if we take sin theta is equal to 1, and that is possible only when theta is equal to 90 degree. And from this expression we are now in a position to define 1 Tesla. So we define 1 Tesla is that magnetic field intensity which applies a force of 1 Newton when a charge of 1 coulomb, positive charge of 1 coulomb, is moving with a velocity v at 90 degree to the magnetic field intensity present there. So 1 Tesla is equal to 1 Newton divided by 1 coulomb, 1 meter per second. So this second and this second, both for coulomb we write ampere second, so these 2 seconds cancel each other, we have left with Newton by ampere meter. So 1 Tesla is 1 Newton per ampere per meter. That's all for today. Thank you and have a nice day.